Finally, this is what you've been waiting for. Right? You've learned some SQL to build tables, to fill them with data, and even single table queries to extract that data. Many of you have been working on that. But the real power of relational databases is relating those tables together. We've drawn pictures of it in ERDs. You've kind of thought about it a little bit in your data dictionaries. But now we're finally going to learn how to get any data out of any table at any time, including all the calculations and statistics and grouping and all those things we learned in single table queries are still applicable to multi-table queries. So let's start. Again, make sure your employees database is ready to go, and just a quick list here of tables: employees, plants, and trips. I'm not using the states, but employees, plants, and trips. In the single table queries, we generated a number of queries that really seemed a little odd because they were still showing ID numbers, and I've been harping since day one that users should never really see those ID numbers. But until you learn this multi-tables technique, there's really no good way to get you comfortable with simple queries without throwing a few ID numbers in. The homework assignment, most of those are stolen from the book with modifications. They still have ID numbers in them, but more often than not, I don't show an ID number, especially an auto ID number, ever in the query results. Those numbers generally don't mean anything. They can simplify finding records, but so can a good GUI. So I'm not a big fan of those. So how do we do this? I've forgotten how to do everything. There we go. How do we do this? To include multiple tables in your answer, we want the fields to come from multiple places. So I want to know who went to Chicago in the second week of February. I don't want ID numbers for employees. I want their names. Maybe I want their phone numbers. I might want to know who their supervisor at the plant is. That's 3 different tables. Not a problem. You include whatever fields you want. You just list them. After the select command, you just say, I want this field and this field and this field and this field and this field. It doesn't matter what table they're in. They can come from any table. Lions Camp in the systems class, I think they told me they're at 50 tables right now. Yeah, that's what I said. I was surprised, but even 30 was impressive. But they're at 50. And some of the queries they're writing are quite complex. Good news is we got 3. And some of the more complex ones, which is Henry Books, has got 7. But the point is, if the tables are related in any way, directly or indirectly, you can get data from 2 tables. So imagine a big ERD that's this wide. You want something from here and something from here. As long as there's a connection, you can do it. So you put the fields that you want in the select command, nothing special there. And then in the from clause, you list all the tables that you need access to. Now here's where things get slightly tricky. Real quick on the board, if I wanted to draw an ERD of my employees table, let me get rid of that one. I have employees that take trips, and employees have work at plants, right? Looks familiar? One plant has multiple employees, one employee works for one plant, one employee takes multiple trips, but a trip is only taken by one employee. If 2 people go, it's 2 records. It is possible to create a query that says, give me a list of all the trips, and give me the supervisor of the person who went on that trip. Not the person, the supervisor. And the supervisor is over here. Well, there's no direct connection. No, but there's an indirect connection. And the thing I want you to recognize is if you want to create that query that says I need a couple out of here and a couple out of there, a couple out of trips and a couple out of plants, you must include the employee table in the list of tables in the chain. You have to create all the relationships between the tables that you're using. There has to be a connection. even if I don't need any fields from the employee table, I still need to include it in my query to create this connection. Make sense? Okay, that ERD will likely come in handy. There's only 3 tables here, so it's not too hard to keep straight. So let's see what my example says to do here. And the example says, add me as an employee. Aren't I an employee already? Let's just take a quick look. Select star from TBL employees. Nice little warm up here. Where last name equals golf. Nope, not there. So that says add me, and there's a reason for this. So we are going to insert into TBL employees. And I'm only going to do a couple of fields here. I'm going to need an emp ID because that is not an auto number field in this database. So I'm going to need the emp ID in the first name and the last name. And I think I know my gender, so let's put that in there just in case. And a plant ID. We'll leave the rest of it out. Then I put in some values. This should look familiar from your build command, right? Some values for me, so let's use a 65, 65, 65, 65, 6. I don't think, oh, that's a string. Don't think there's one of those in the database already. If there is, I'll get an error. Before class, Matt was asking apostrophes, quotation marks, does it matter? No. Changes colors. So you think it must make a difference. Not really. As long as you start with the same quotes, apostrophes, and end with the same thing, you can use them pretty much interchangeably. I'm just so used to typing quotes, but then I'm an old dog programmer and we didn't get to use apostrophes once upon a time. Now we can. Seems to me that apostrophes would be easier because you don't have to shift. But I'm so used to doing that I do it. The only reason I would pick quotation marks over apostrophes is if my string had an apostrophe inside. That way I can embed the apostrophe and not have to do all kinds of double apostrophes things or whatever we're supposed to do. So quotation marks, single apostrophes, I don't care. I don't even worry too much about consistency there. So first name Volker, last name Gall, gender male, plant ID. This is a number. Right, that one is an auto number field. Let's say I work in plant number 1. And hopefully now I can execute that. Good. Go back up here and see if I'm in the database. I am. It's got nothing to do with multi-table queries, except it does set me up to prove a point a little later. Want me to wait? Say wait. Okay. Display the employee name, the trip date, and the destination for every trip. So here's our first multi-table query. I want the employee's name. That's the employees table. And I want the trip date that they went on. That's in the trips table. And probably a destination, I've already forgotten what I want. So let's start. You build the query the same way. We're still selecting data. I want the employee's name. I could concatenate it. Let's just simplify here and say first name, comma, last name, the trip date and destination. Trip date, destination. So this is just like what we did before, except the field list now is coming out of 2 different tables. And there's no limit on 2, 10, 30, 50. Create some pretty nasty looking queries, bringing all 50 tables in and a little bit from each one of them. Perfectly legal. But now the tricky part. From our 2 tables. So that's the employees table. I think it's TBL, yeah. And TBL trips. So that's the basic setup. Again, if you're pulling fields from tables, maybe I need a table that's in between, but I don't have a field here. You still have to list the table. You have to complete the chain. So why that ERD comes in so handy when you're writing queries, because you can see, okay, if I want from here to there, here's the quickest way to get there. Quickest isn't necessary. Sometimes it's better to go a long way, but let's not get into that. Got to make the connection between all of the tables. So how do we connect them? Well, that's another question. The way we connect them is using a join command. We can also do it with a where command, but I'm going to ask you, and it says so in my notes down here in yellow, you can join using a where command. I'm going to ask you not to. A where command to me is used for filtering. I want the ones that are trips to Chicago. The where command in old SQL was the only way to join tables. In new SQL, there's a new command, so I'm skipping right over all this stuff that uses the where command. And there's the big yellow warning saying I put these in here for reference, so if you see somebody else's query, you know how they work. But I'm not going to ask you to join tables using a where command. I'm actually going to ask you not to. There's a command that's set up now to join tables. It's the join command that is used to connect tables. I'm going to skip ahead again because last semester, I'll give Adam Hulte a shout out here. Adam Hulte discovered that there is a new version of the join command that I didn't know about till last semester. And so it pushed a little later in my notes. We're going to have to come back here later. But for right now, let's learn the quickest way to join tables. And that's using the join command and the using clause. To join tables. This isn't good enough. If it was a where clause, we could get away with it. We list the tables, and I'm going to start right away with an alias. Remember, an alias is just a rename. We did it to fields and calculated fields. You can also rename, bless you, you can also rename tables. Changed my mind, took it out. Now we need to join that table with another one. When you do a join using a using, with a using command, you probably don't need an alias. It's another advantage of using. Takes away the requirements for an alias. And then we can link the tables together. What field do these two tables have in common? Again, the ERD that I slapped up on the board there doesn't show it to me, but your typical ERD shows you the linking fields, right? Now you know why. Because when you're writing these queries, you need to know which field links the tables together. You need to know that. You, the query builder, have to know the linking fields. Not the table names are nice. Yeah, we need those too. But what's really critical is they have an employee ID in common. Now we could keep going. That's it. That's the new and improved way to join your tables. And if you have multiple tables that you need to join, if we needed to join plants to employees to trips, you just put another join in here. You got 50 tables, that'll be 49 joins. And for each one of the joins, you have to designate how it's linked to that table, which field does the linking. Once all your joins are done, then you can get back to using where clauses and group by clauses and having clauses and order by clauses. All of those clauses still apply, and what's cool now is you can apply the criteria to 4, 5, 10 different tables if you want to. I can sort by, let's start with that, order by trip date, which is from the trip table, followed by last name, followed by first name. I'm now sorting by three different fields from 2 different tables. Once you've joined them, think of them as one big happy table. You can make the trip date descending. All the stuff you learned in single table queries, including subqueries, can be applied to joins. So these are sorted by trip date. And within the dates, here's all the 223s. They're sorted by last name and then by first name. And this is much easier to read, right? Than employee number 1, employee number 17, employee number 37 went on this trip on that day. This is much better. We've now joined the tables. One thing I do want to point out here, though, I'm going to take the trip description out of the sort temporarily here and run it again. Where's Volker? Sounds like I need a red stocking cap and a bunch of people all around me. Lost Waldo. Where's Volker? It's not there. How come? I don't have any trips. When you join tables together, you only get, by default, you only get records that have entries in both tables where they have something in common. There is no trip with an employee ID of 6565 so on. It doesn't exist. That's by design. You said, give me the list of names, give me a list of trips to destinations and give me the people who went. There's no trip for me, so I'm not on the list. Question so far? This is your best example for how to link tables. Because in most of your tables, this works. The only reason it doesn't work, think back to your database, no, your SQL build part 1. We've got employees who are linked to supervisors. What do you put in here? Employee ID or supervisor ID or what? Bottom line is neither. The using clause only works if the two tables linking fields, the primary key and the linking field, have exactly the same name. It only works if they have exactly the same name. So what if they don't? And this is very possible. That self-linking table that we just talked about with supervisor ID, we can't call it employee ID and employee ID. It's two fields with the same name. That doesn't work. Right, so we need some alternative, and we gave it a different name. And there's no rule in relational database design that says that the primary key in one table has to have the same name as the linking field in the other table. They don't have to match. Typically do, because it makes stuff like this a little easier, but it's not required. So what do we do if there is not a field? We're going to have to pretend here, because with my new version of the employees and plants and trips table, they're all have the same names. So we're going to have to pretend. Let's create a list of people and their supervisors. Let's see what supervisors look like. Supervisor has a foreman. Okay. So we want the first name, last name, foreman. And let's add the plant name just for grins. Two different tables. When you're building these queries, first things first, read the assignment. What fields do they want? Add them. Your boss says, give me a list of employees, their foreman, and the plant name. You want them in that order? Doesn't matter. Okay, fine. Concatenated? Doesn't matter. Okay, fine. The concatenation still works. We can do that. Now we've got two plants. So we have to go from TBL plants I tend to go with the parent first. There's no rule that says you have to list the parent table first and then the child table second. I normally look at my ERD as I'm trying to connect these things. I start with the parent, then work to the child. It seems to help me make sure that all the connections are there. And I want to join that. And in my notes it says inner join, and I probably should have put that up here. Inner is optional. It's the default type of join. A little later we're going to see an outer join. If you want an outer join, you must request it. Inner join is the default. The word inner is default. You cannot avoid the join. Okay, the join has to be there. If you don't put inner in there, I don't say anything about it. I put it in there here just to clarify the difference between inner and outer. What an inner join basically means is give me only the records where everybody matches, which is what we got up here, because Volcker wasn't included. Inner join, TBL employees. If the table names do not have the same key or linking field names, I'm just going to say linking fields, the two fields that we tie together in the two tables. One of them is actually a primary key. But if the two fields that we're using to link do not have the same names, then you have to use an on clause. The on clause then designates how those two fields match. Here's the hard way. On TBL plants dot. Let me show you this for a second here. Plant ID equals plant ID. Does that make any sense, programmers? No. That's like saying make a line in your program that says A equals A. What's the point? Okay. You're smarter than the average SQL, so you see where the plant IDs match. But it's the same name. Which plant ID are we talking about? In any of these queries, if there's a conflict, as in both tables share the same name, remember our students and instructors tables, students had first names and last names, instructors had first names and last names. Same fields. If there's a conflict, if you will, or an overlap, an ambiguity, I think that's the term that shows up in the error message. If there's an ambiguity, which plant ID are you talking about? You must qualify the field name. If the TBL plants plant ID is equal to the TBL employees plant ID, then join them. Basically what that says. Why wouldn't they be equal? They would be. They have the same name. That's where this using clause came from. I'd have to go do some research to find out when it showed up, but I didn't know about it till last year. It's not in your book. If it's not in the book for me when I was learning SQL, that means it doesn't exist, because that's all I knew. Since then, I've found some new things with helps of students who were Googling things to say, what do you know about using? And I went, nothing. Send me a link. Now I know, it's in my notes. But this is so common, was so common, on same name equals same name in two different tables, that they gave us a shortcut. Both of these work. I recommend this one because it's a whole lot less typing. You don't have to qualify things, which is really cool because it just says, I assume there's an employee ID in both tables. And that you want to check them from equality. And yeah, about 99% of the time, that's exactly what I want. So where this command came from, I don't know, but it's great because it simplifies our queries significantly. I've not tried it in Access. I should go try it and see if Access recognizes a using clause. But MySQL definitely does. So this is another way to link them. Repeating this table name gets really annoying if you have to do a lot of these joins. So this is where the aliases come in. This is my plants table, so I'll call it P, and this is very common to assign a single digit or single character alias to the tables. Now this table is an alias of P, and I can simply say where the P plant ID is equal to the E plant ID, and it makes that a little easier to read. Pick a good first letter, and they don't have to be single letter aliases. You could call it plants. You don't save much when you do that, TBL prefix. But you can name them whatever you want. And once again, once they're joined, I can do whatever I want and say something like order by plant name. And now all my Coloma plants are together, and here's all the people that work for Richard Femmer. Here's all the people that work for Kesmerick and Polonia. But notice that the foreman and the plant are one-to-one, so really that's kind of redundant, but that's okay. We can see for each person. If I reorder this by employee name, I'll see the employees and where and who they work for. So it's the same result. I can do this query using the using clause. You just take all of this out and put in using plant ID. Give me the exact same answer. Two different ways to link tables. If you want to experiment with the where clause, you can. I don't think I'm even going to take time here to talk about it because I never use it. You don't use a where clause to link tables. You basically take the inner join out and put where in there instead. Kind of. It's in my notes if you really want to see it. But I use using as my first choice. I fall back to on when the two keys or the two linking value fields don't have the same values. Excuse me, same names. And you must use that. So this is first. Questions? Let's see what I skipped over in my notes. Okay, here's an example of a where clause. You just list the two tables. You still have an alias because it makes this a little easier to understand. Okay, but to me, the where clause's purpose in SQL is to filter records, not to join tables. In a way, if you think about it, it's filtering because it only shows me records where there's a match in the two tables, right? Remember, Volcker Gall doesn't show up. So in a way, it's filtering. But really what I'm doing there is linking two tables together. Here's the join. That's the one we just did. If I'm required to use the on clause, I like to have the aliases. It makes this a little easier, a little less typing. What if I wanted to display the student ID here? Let's come up here. If I want to display the plant ID, I can do that. But now I have a problem, right? There's an ambiguity here because plant ID is in both tables. Which one do you want? Down here, I'm getting an error, and it says plant ID in field list is ambiguous. Meaning, which one are you talking about? Okay, it's plant, so might as well pull it from the plant ID. But a reasonable SQL programmer would go, why do you care? They're both the same. They have to match, otherwise we don't even show the record. Why do you care which one it comes from? But they do. If you use the on clause, you must, every time you use a field that's common between the two tables, you must distinguish between them. You must qualify, is what this is called. I've had some students in the past who insist on qualifying every field. That way you don't have to worry about, do I need to qualify it or don't I? Okay. I think it's a waste of typing. I only qualify the ones that I need to, the ones that the two tables have in common. But if you're looking at an ERD, what fields do my two tables have in common? Sometimes hard to tell because the ERD doesn't have a field list. To go to the data dictionary or to the database itself to figure that out. So if you're not sure, you can qualify them all, or you can do what I do, run the query, and when you get the ambiguous message, go, who you complaining? Okay, I'll go fix that. But you can qualify every single one of these. Just make sure you use the right table. Don't try to say P first name because there isn't one. But you may qualify them. But again, the SQL programmer's going, that's a stupid question. Who cares? The plant ID is the same. That's why the using clause doesn't require it. No complaints. I did exactly what I did down below here. I put plant ID in there. I put plant ID in there with no qualifiers. Doesn't matter. As long as it's the linking field. But you know what I feel about adding linking fields. What good is that number in my results? Not much. So you don't have to qualify. Again, if you overqualify, I'm not going to complain. I will cringe, but you'll never see it, so you won't know. It doesn't matter. If, however, we're going into two tables here, we want let's pretend there's a foreman's first name and a foreman last name, and the field name is just first and last, then it's redundant again, because this it can figure out. But other fields that are duplicated across tables, you have to qualify. Because the employee's name and the foreman's first name, those are two different fields. They're not used for linking. Which first name are you talking about when you put it up here? Again, imagine if we had a first name and a last name for our foreman, and they were called first name, last name. It would look something goofy like this. Give me the first name and the last name, and the first name and the last name, and wait a minute. You want this twice? Well, no, this is for the employee, and this is for the fall. Even the using clause can't sort that one out. You'll have to qualify every single one of these, saying from the employee table, from the plant table. You'll have to qualify them. We don't have those. I'm just making it up as I go. That's one reason why some database developers say, I will not have two fields in my table with the same name, ever, except linking fields. So it's student first name and student last name and instructor first name and instructor last name and employee first name and foreman first name. Every one of them has a different name. That way they never have to worry about qualifying them in their query. That's an approach. I don't know that it's necessary, but it's an approach. Because if there is an overlap, all I have to do is qualify them in my query. It's not that hard. Questions? Okay. So we linked them, we used the join, we got the aliases. Inner is optional. I like to put it in. This really needs to move up. The on clause, on is part of this one. This one. Inner join on. You must use on when these two have different names. Must. If they have the same names, I recommend using, which is coming. Here it is. First name, last name section from TBL student. These aliases aren't even necessary. I caught those the other day, but I haven't had a chance to fix my notes. There's really no reason to provide an alias there because I'm not using them. If, however, I had another F name and L name here, then maybe those would help. Using only works when the primary key and the foreign key have the same name. The parentheses are required. That seemed a little weird to me. Those parentheses are required because there's never a list in there unless there's multiple fields, but those are pretty rare. You don't need to qualify your fields, but half the time I don't display them anyways. So what other examples we have over here? We did the first name, last name, trip date, expenses, and plants, and the foreman. Ooh. Okay, let's see if I can keep that on the screen. Let's build it. So I want to select the last name, first name, concatenate it. Oh, all right. So I put a plus sign in between, right? Jess is smiling. So you guys are on to my trick questions. It's no good. I can't use them anymore. Okay, no, I can't do that. So what do I use instead, Jess? What's the name of the function? Help her out. Concat. Don't do that. That'll get you smushed data. We don't want any smushed stuff. Caught a lot of you in your business class jumping to the other class now. A lot of business classes with smushed error messages. First name, let's give it an alias, and we'll call it employee. And then it says we also want the trip date, okay, and the expenses, and the plant name, and the foreman. Okay, so that's the field list. That's how I would normally start your homework assignment questions. What fields do they want? Get them in there in the order they're requested. Now, I need to put my tables together. First name, last name comes from employees. From employees. Join, or let's do what I said I would do, inner join. TBL trips using emp ID. That's no different than up above, but now I've added the plant to the mix. So here's how you add another one. Another inner join on another line is what I normally do, but you can string all these out. Remember, MySQL is like a lot of the other languages. They allow you to put tabs, spaces in between your commands. Now I want to join that to TBL plants using plant ID. Now what's initially confusing to me is how does SQL know that plants is linked to employees, not to trips? It doesn't. What happens behind the scenes after doing a little reading is this join happens first. So now I have this big table, sort of, with a bunch of trips and employees together. And somehow, magically behind the scenes, the plant ID from the employee is also included in that. It's not displayed, but it's in there somehow. And once these are joined, these two together have a plant ID. So joining this one to plant ID, that works. How is it? Who cares? It's magic. It figures it out and it links them together. Wouldn't have I been better off to say from TBL plants, join to employees, join to trips? If it makes more sense to you, sure. Because I kind of did that ERD inside out, right? I started with employees and then went that way and then went this way. I don't think it's going to make any difference. And then my list over there says for people who went to Chicago. So now comes my where clause. So where the destination equals Chicago. Wait a minute, there's no destination up here. Doesn't matter. It's like in your single table queries, you did a lot of queries where the where clause or the order by clause even isn't included. Whatever you're sorting by isn't included in the output. But I just want to make sure this is working. So I'm always a chicken, and I put destination in here. And then if once it's working and I verify, yes, everybody's going to Chicago, then I pull it back out again. And how many records did we get? 25 rows. Sounds about right. 25 trips out of over 200 trips to Chicago. So here's my concatenated first name, last name. Here's the destination. Yep, they're all Chicago, so I could clean this up because really, once you verify the query works, that's a lot of redundant data. I might save this query like they did in your Access class and call it Chicago trips. Could do that. But here's all the information from 3 different tables at once. And now, just as a demonstration, I'm going to copy this, and you don't have to follow if you don't wish. And instead of starting with this, I'm going to follow my ERD, and I'm going to say start with TBL trips, join to employees using the plant ID, because if that was a complete ERD up there, we'd see that line. You'll see where I'm going? Okay. And then join that to the trips table using the employee ID, and now I'm doing a little better job of following my ERD up there. I don't know if I'm going to get them in the same order. We started with Mr. O'Donnell and then Tina Clover, so let's see what we get here. Uh-oh. TBL trips. What? Oops. This is supposed to be plants. Not keeping an eye on me. Plants. There we go. And now we started with Tina. Notice Mr. O'Donnell is gone. He's hiding somewhere. Maybe he's up there. Oh, he's there. Okay. So I got the same order. That was lucky. But again, the order here is immaterial because I didn't ask for an order. Really should. But I joined them in a different way, got the same answers. So how you join them doesn't seem to matter. It doesn't matter if you're using or the on clause. Doesn't matter what order you link them. Somehow behind the scenes, my SQL figures it out. Now, having said that, let me scare the heck out of you. And when there's 50 tables, sometimes it does matter what order you join them. There could be these circular joins sometimes where we can come in from here, or we can come in from there. And sometimes I found that the order makes a difference. If you can't get the answer you're looking for and there's another way to join the tables, and I don't think this is going to hit you in the homework assignment. Just talking in the future. If you don't seem to be getting the answers you're looking for, try joining the tables in a different order, see if that makes a difference. Because I still think what happens behind the scenes here is SQL links my plants to my employees. It creates kind of this temporary table. It's got all that stuff in it. And then it links the trips to that. And that sequence might make a difference. Let's stop there. Now that Tyler's ducked out. Let's stop there for today. That gives you a half hour with me in the room working on whatever queries you're still working on. It should be, I think, single table queries are now on Friday, right? So you can be working on those. And I'll be here to help you. How many are you going to be gone Thursday? Okay, Thursday we'll continue on, and there'll be a recording so you can go back to that. Give all the rest of you a lot of credit for not ducking out on spring break early. Probably got another reason. It doesn't matter. Okay. So Thursday we'll continue on. I hope to do kind of the same thing, maybe 45 minutes of talking about outer joins and whatever's coming next, and we'll finish up this unit, my guess is after break. So the multi-table queries assignment itself will not be formally assigned until after break. But for those of you that are done with single table queries, and there are quite a number of you, there's no reason you can't jump in here and deal with some of the earlier questions in Unit 2. Join these tables with these fields. If you can't figure out the answer, then maybe you leave that one for a while, because maybe we haven't talked about it yet. The most common thing in all those homework assignments is joining these things with the right tables and figuring out who's connected to who, and oh my goodness, I need that table in between. We haven't talked about calculations yet. I think you could figure that one out. Once the tables are joined, you can calculate using values from any table. So I could take value from over here and value from over here, multiply them together to come up with something new. Once they're joined, think of it as one big table and you can do whatever you want. Filter by all fields from any tables, order by fields from any tables, calculate using any fields from any tables. It's as if we have one big, huge monster database once you've done the joins. You have to repeat those over and over and over again, unfortunately, but that's not hard even. Okay, so you're in lab